Yeah, so it has mm, these all steps, right? These are like, yeah, state the null hypothesis, level of significance. You have to decide like how much I am okay to accept the criteria. So these are like 5%, 10%, and 1% mainly level of significance. And what does it says? Based on that, you will check the t value, which is your expected t value or whatever z value. Based on that, you will compare your statistical t value. That is what you will calculate. And you based on that t value and the your critical value, you will actually, yeah, so critical value is actually coming from the level of significance, which is getting from the table actually. And based on table and whatever you calculated, you will compare, and either you will reject the null hypothesis, you are not able to reject the null hypothesis. These are like, we talked, there are two type of parametric versus non-parametric. Major assumption was parametric will have normal distribution and their population mean is the, sorry, standard deviation is given to us in some of the circumstances. Non-parametrics, we do not have any assumption for the population distribution. They are not normally distributed, that's all. And we can apply majority of the places where non-parametric parametric is cannot be applied, so you applied non-parametrics. In this you can test actually this size square and all to check the goodness of fitness of the curve. Yeah, so we discussed this, we were, so t test was
I
based,
think one discussed on this.
yeah, we discussed
Yes, it's test.
z test, and z test can be two use case. F test, ANOVA, it is like more than two groups. Non-parametric, that is like square, Man-Whitney U-test, Kruskal Wallis U-test. So yeah, I was also going through the how we do in Python also. So there are packages which will help you to calculate these stats for you, and you don't have to worry much. You just have to come up with your significance level. Based on that, you will calculate your test statistics and sorry, the critical value and statistics. So chi square, let's talk about this. Chi square actually, this is non-parametric test. So here it is. Yeah, two thing we test is goodness of fit. Meaning is like, classic distribution kind of. Suppose binomial distribution. It will be something like this. Probably this is yeah. Let's assume not binomial. Let's so you assume like your data is actually Poisson distribution, something like this. Then you will check is your data is really distributed according to Poisson or not. That is like goodness of fit test and test of independence of two variable. Is there any correlation between two variable or not? Are they are independent or not? Suppose you did some experiment, you are actually calculating two things. Or one thing is, uh, you can say you are calculating, yeah, two variable of any person or people, something like height or weight. Or whenever you do experiment, you calculate pressure, temperature and volume. Those are some. So you want to check, are pressure is related to temperature or not, height is related to weight or not. So independence of two variables, something like that. You when you are wanted to calculate or check test, they are dependent or independent, you will use this one, non-parametric test, and in that you will go for chi-square test. See, goodness of fit is nothing but set of observed value versus expected theoretical comparison. So this actually comes like you are calculating, doing one experiment like how frequently people are coming in a queue, meaning after how much time. First person comes in 1 minute, second person is coming at 3 minutes. So you want to plot that distribution of 3 minute and 1 minute. To you will do what, you will have stopwatch and you will calculate that values or note down all the values, and later on you will plot them. This is how you do experiment, and these experiments are actually you need to plot on some graph, or you want to check what is the distribution of that graph. So that is where you have to do this testings, goodness of fit test. It is like, you are checking with theoretical, is it this data is Poisson distributed, binomial distributed, or what distributed, or exponential distributed.
Rishi, for this also data we will be getting in some Excel format, and like
Yeah,
business will
so
place a requirement, that will be our questions, right? Like
correct,
which
correct.
one to be
So
chose.
most of the time this is like you get a data. Someone can ask, is the data is what type of distribution it is. He will give hint also, like this is likely to be distributed either this, either that, 2 3 distribution you can say max. So based on that assumption, like it is mainly you can say Poisson and exponential, or in that also he, meaning the person or in a company, they will know like what is this type of data is mostly fall into this distribution. So you will calculate this, uh, this expected frequencies and all, and observed frequency you have to calculate. This is to be calculated and this is given, and based on that you will calculate the fitness. So it is like if they are too much different, this chi-square value will be higher. So the formula is quite straightforward. You can say this is observed minus expected square upon expected. So if they are too much different, this value will be higher, otherwise it will be lower, or it is going to same. If there is no difference, these will be same, then chi-square value will be 0, right? So similarly, if you want to calculate independence of two variable, you can put values 1 mean here and values 2 mean here, and similarly you can calculate expected chi-square for this between two variable, and it will come something same. So let's assume, I think, let's see what all the conditions when we apply chi-square test. So observations are recorded and used to collect on random basis. It should be randomly collected. All item in a sample must be independent. It is not like one person's height is independent to other person. That is for sure. Similarly, if you are conducting some uh, that pressure, volume, temperature experiment, it should be also independent. You can assume we have one experimented did in the morning, second one you did in the evening, and they are independent to each other. Okay, so there is one more condition in each of the group. They are saying we should have less than 10 number of values, or very few items should be available. If in a group we have a number of item large, it should be at least 50.
Rishi, I have a doubt here.
Yes.
In the previous test also, like the T test, that test also, they had mentioned like the it should be within a 50. Here, this 50 means like 50 test cases only we should be preparing, or within only 50 test records, we have to perform this.
No, no, at least they are talking about. So at least 50 is
Minimal, okay. Minimal, it should
minimum.
be like 50 data should be present, kind.
Yeah.
Okay.
Oh, okay. They are saying at least 50 in a group. So because you want to check, is there a correlation between or is there any relation between this group versus this group? Suppose you calculated a school 1 marks versus a school 2 marks, kind of, or two groups of people, or where you actually perform some experiment, kind of saying instead of marks, let's come up with some experiment saying you did some drug experiment, or so you want to check either they are having same type of relation or they are having some different relation. This is where they use independence test, right? We are checking are they dependent or not, two variables, or they are having some relationship or not. So chi-square has a parametrics used for. So this is a when we have population variance given and we have a sample variance calculated, then actually we will use, and then the formula becomes sigma square upon sigma square of population versus sample, and minus 1 is actually multiplied as the n minus 1. It comes like how to say, suppose you have 10 persons data, you able to calculate the 9% data, right? You are able to estimate 9 persons some information. So obviously 10th person information you can extrapolate, or you can definitely guess actually. So in that case, that is why we come up with n minus 1, where n will be number of population, a number of sample actually, number of items in a sample size, that you can say directly. And this value is nothing but chi-square value. So you are checking actually their variance multiplied with n minus 1. This will be either 1 or greater than, sorry, yeah, lesser than 1 or greater than 1. So if it is 1, so you can say population and sample both are same actually. Otherwise you will say both are different. Similarly, we have one more test, chi-square, sorry, Man-Whitney U test. This is actually performed on also non-parametric test. It is, and it is so two of the independent samples which are selected from the population having same distribution. So it is like, suppose you are calculating some waiting time and arrival time of the data, and you are checking are those data which you calculate they have same distribution or not. It is also say true non true counter test of similar to t test actually. It is applied on non parametric test. It is applied on non parametric test. This actually when sample size are small and population are not normally distributed. So when your sample size are small, you will apply this man-Whitney test, and where you so it is based on the comparison of every observation of the first sample with the observation in the second sample. So you are actually comparing within same sample actually and trying to make some statistical analysis. Maximum value of u can be n1 into n2. That is like number of sample in first group into number of sample in the second group, and its minimum will be 0 because any of the sample can be 0. In that case also you can check directly saying data which we got, it is what type of distribution it is. There are two types. This is also known as rank test and Wilcox Wilcoxon test. Wilcoxon, yeah. Man-Whitney Wilcoxon test and Man-Whitney rank sum test. So they have some certain formula you have to apply and decide how we are calculating these values based on u, and actually it is checking are they, you suppose you calculated, you can assume like this in session, or you can say class 8th, you performed, you got your rank right, 1 2 3 in school kind of. So you were at second rank in the 8th class, and you are actually in the ninth class, you are also at second rank suppose. So how you will make sure like your day or your performance was consistent or not? Is it by luck you are getting on the second rank every time, or you really worked hard and proved yourself that like your rank is consistent across second both of the class? In such of the scenarios, you can apply this test and figure it out. Your ranking was really according to meaning your performance, or is it just by randomness? So that is where you can apply such test, and or this is only talking about you is not the case. Actually you have to compare with each other, like yeah, what is a relationship between why our rank is like second and then third kind of, then you will calculate these values. So you can see here n1 is number of size of the sample 1 and r1 is nothing but the sum of rank in the sample 1. So sum of the rank is nothing but if you have 4 students you can sum it 1 2 3 4, this will be coming 10 minus your rank or number of sample, actually 4 into 4 plus 1 divided by 2. So you will get u1 value. Similarly you will calculate, oh okay, so instead of going into 9, suppose your rank comes in some all India rank test. Suppose 100 people are there. Now your rank is 30. How actually your rank in the small group versus bigger group, like are they really making significance, or your performance is bad or good? Suppose you want to calculate that in comparison to, or both performance are same. In that case you can apply such test to identify like your performance is better or good, because it is 100 right. Still you can say yeah, here it is 2 rank out of 4. So you can say 100 out of 30 is not maybe or maybe not same actually. So this you have to test. In that case, you can apply this. mm, what is mean man Whitney test here. So you will calculate u1, u2, and there's some knowing the algebra and all, you will get u1, u2 also this value n1 into n2. So I think this is nothing but derivation how we are getting u1 plus u2. Based on that only, I think I forgot to add this man Whitney test formula. Mm, So in we can go through example later, yeah, after. So let's remember we have this man Whitney, and now one more is Kruskal-Wallis S test. So in that we are actually comparing on more than two or more than independent sample, and they have different sample sizes also. It is actually extension of ANOVA, and no, it is extends the man Whitney test just for two groups. It was, but ANOVA was man Whitney was for two groups. Now it is for more than two groups, and you will have suppose three groups and four groups. Now, so one way ANOVA is actually it is same. It just it is on rank. ANOVA is on variance actually. If you remember sigma, it uses rank instead of actual data. You need to have a rank of each of the data sample. It is not norm. Assume data is not oh, okay. So normally distributed. Oh, this H is saying we use the test statistic H. So H is when we are saying, right, there is one classic distribution you will get. When we say N normal distributed, I need to check H is like what size. N is also H is also one type of distribution. Or all the test statistics you will get from the table actually. So these are only three tests I wanted to talk. There are many, but we can skip for time being. Yeah. So, any questions?
Uh, this Kruskal one, I was not able to understand it.
Kruskal, last one.
Yes.
So, it is just extension of ANOVA. It is just talking about more than two groups. So, why they say is like, so are you available? Okay, wait. So, Kruskal actually talks about more than two groups. It is same actually, man Whitney only, but more than two groups, and then actually the formula will little change, and the formula will also will be similar, I guess. N1 into N2 into N3 will come, and then we can check what is the formula and how we can apply. Any more?